Hello, good morning. This is Farhan Shakil from the Republic 2.0, and today we are going to solve the January 25, the Pure 1 Edexcel paper. So the time frame for the paper is 1 hour, 30 minutes, right? And we just need to cover it up in that much of time. So we'll start from the question number one. Question number one is often either from the differentiation or integration. And we just need to integrate 8x cubed minus 6 root of x minus 2 upon 5x cubed, bracket close, into dx. So what I'm going to do, first of all, I'm just going to split it down, and I would be having 8x cubed dx minus 6 root of x dx minus 2 upon 5x cubed dx. And right after that, I'm just going to take the constants out of the integral sign, and I would be having 8x cubed into dx minus 6 x to the power of 1 by 2 dx minus 2 by 5 x to the power of minus 3 dx. So now I'm just going to apply the power rule of integration. And what was that? We just need to add 1 into the power and divide it by the same power. And then minus 6x to the power of 1 by 2 plus 1. And then 1 by 2 plus 1 over here as well. And then minus 2 by 5 x to the power of minus 3 plus 1 divided by minus 3 plus 1 plus c. Do not forget the constant of integration. And now we'll be having 8x to the power of 4 divided by 4 minus 6x to the power of 3 by 2 divided by 3 by 2, and then minus 2 by 5 x to the power of minus 2 divided by x minus 2 plus c. And now I'm just gonna, solve these fractions down, and I would be having 2x4 minus, this 2 is in the denominator of the denominator. We just need to multiply 2 times 6, and that is going to be 12 upon 3, which is 4x to the power of 3 by 2. Minus minus is going to be plus, and over here I would be having 1 upon 5 x to the power of minus 2 plus c. Remember, whenever you have been given a question regarding integration or differentiation, you need to write the simplest answer. So the simplest answer is going to be 2x4 minus 4x to the power of 3 by 2 plus 1 by 5 x to the power of 2 plus c. Powers look good when they are positive. Now, we'll get to the question number 2. And the question number 2 says that we've got a point A which has coordinates negative 2 by 3 and 5, and the point B has coordinates 7 root of 3 and 8. The straight line L1, we've got a line L1 which is passing through A and B. So what we're going to do, we need to show that the gradient of L1 is P root of 3, where P is a rational number to be found. You should show each step of your working. So what are we going to do now? We just need to calculate the gradient of AB, right? So for the first part, I'm going to calculate the gradient of AB, right? I'll mention the formula at first. Gradient of AB, which is change in Y divided by change in X. Now I'm just going to plug in their coordinates, and their coordinates are, for example, if you're talking about A, you've got minus 2 root of 3 and 5. So that is going to be 5 divided by minus 2 root of 3. And then you've got 7 root of 3 and 8. So it would be 5 minus 8 minus 7 root of 3. Now I'm just going to solve it down, and I would be having negative 3 divided by negative 9 root of 3. Now the thing over here is that we have got a square root in the denominator, right? So, there are two ways to do this thing. Either we can just simplify these bases 3, or we can just simply rationalize it. What I'm going to do, I'm just going to write it like, canceling this negative and this negative. I'm just going to write it down like 3 to the power of 1 divided by 9 times 3 to the power of 1 by 2. And now I'm just going to solve it down. So I would be having 3 to the power of 1 minus 1 by 2 divided by 9. And that is going to be, the gradient of AB is going to be 1 by 9 root of 3. So what does that mean? That you have got the values of, value of P, and that is the root of 3. He talked about P, so we need to mention that. Now, in the B part, we need to find, L2, which is perpendicular to L1 and is passing through A. So we have got the point, and by having this much information, we have got the slope as well, right? Since the slope of L1 is uh, 1 upon 9 root of 3. So in the second part, slope of L2, it should be the negative reciprocal, because we've been talking about it, because it should be a negative reciprocal since the L1 is perpendicular to L2. So the negative reciprocal of this thingy has to be negative 9 divided by root of 3, which doesn't look good. You still got a square root in the denominator. So what I'm just going to do, I'm just going to rationalize it for once. 9 root of 3 times root of 3 divided by root of 3. And I would be having negative 9 root of 3 divided by 3, because square root of 3 times by square root of 3 has to be 3. Now by just cancelling them up, and slope of L2 comes like negative 3 root of 3. So that is how you're going to find out the slope of L2, negative 3 root of 3. So I've got the point as well. So I'm just going to using point slope form. We need to use the point slope form, which was y minus y1. The point is A. And what was your y1? The y1 was supposed to be 5, right? So y1 has to be 5 equals to negative 3 root of 3 times x minus x1. What was your x1? It was, I guess, minus 2 root of 3. Yep. So you've got minus 2 root of 3 over here. Now I'm just going to simplify it down, and I would be having y negative 5 is equals to negative 3 root of 3x minus minus plus plus minus minus. 3 2s are 6, root 3s are 3. And now at the end of the day, you would be having y is equals to negative 3 root of 3x negative 18. And then this 5 is just getting subtracted over here. It would get added over here, plus 5. So you would be having y is equals to negative 3 root of 3x and negative 13. That is the required equation of L2. So that is how we should be solving it down. Yep. We're done with question number 2. And now we have got this question number 3, which says that the population of the town was monitored exactly 5 years, which is the time the monitoring began, and the population was 58,000. Exactly 10 years, we've got the points over here. And what are these points? That we have got 5 for the time, 5 years, and 58,000 as the population. You can consider them to be a point. And exactly 10 years after the monitoring began, the population was 65,000. So what does that mean? 10 years and 65,000. You could have these two coordinates. Given that, you've got the model of the population versus time, and that is p square is equals to a plus bt cube, where a and b are the constants, and we need to find out the values of a and b. So we can easily do the question number A by just plugging both of these points in this equation, and getting two equations in terms of P and in terms of A and B, and then just solving them simultaneously. So the part number 1, first of all, the given model. If you talk about the given model, we've got the given model, and that is P square. That is P square is equals to A plus BT cube, right? So at the first point, which was 5 years, and if I'm not wrong, 58,000. 5 and 58,000. I'm just going to plug this point into this equation, and I would be having 58,000 square equals to a plus b times t cube, which is going to be 5 ka cube, right? So once I've got these things, I'm just going to solve it down. The square of 50,000, 58 square, 58,000 square, or we can just simply keep it 58 as well, because thousands was constant. So I would be having, 58 square, and that is going to be 3364 for now. I'm just skipping the 1000 part for now. And a plus 125b. That is your equation number 1. Now, similarly, at the other point was 10 and 65,000. So you would be having 65,000, right? So you've got 10 and 65,000. We're just going to plug it in. You can skip the 1000 part. And the above equation is going to be 65 square plus is equals to A plus B times 10 ka. So at this point, you've got, you need to plug this 10 and 65,000 in the above equation. So I would be having 65 square A plus B 10 ka cube. And that is going to be 65,000 ka square. 65 square is 4225. 4225 is equals to A plus 100,000 B, right? So we have got this thing, and that is going to be equation number 2. So what I'm going to do, I'm just going to get the value of A from equation number 1 and plug that in equation number 2, right? So from 1, A is going to be, you can easily see that. I'm just going to take that 125B to the other side. 3364 minus 125B. So now equation number 2 would become, equation number 2 becomes 4225 is equals to, in place of A, I'm going to write 3364 minus 125B, right? And then I've got plus 1000B as it is, right? So by just solving it down, I'm just going to take the similar terms to each side. 4225 minus 3364 is equals to 1000 minus 125. And that is going to be, 4225 minus 3364 is going to be 861. And 1000 minus 125 is basically 875. So it should be 875B. So by dividing both the sides by 875, I would be having the value of B as 861 divided by 875, which is going to be 0.984. Now I'm going to put this value into the value of A, right? So putting in A, what was your equation number A? This one, right? I'm just going to plug that value over here, and I would be having A is equals to 33. It was 64 minus 125 times 0.984. And by just solving it down, times it by 125 and you'll have 123. So A is equals to 3364 minus 123, and that is going to be 3241. So that is how you'll eventually get the value of A, right? So you've got A and you've got B, and that's it, right? So the modeled equation would be changed a bit, right? Because you're going to plug the values of A and B. According to the model, exactly T years after the monitoring began, the population was 85,000. We're going to keep it 85, right? Because we're just skipping the 1,000 part. Making your method clear, find the value of T, giving your answer to the 1 decimal place. So we just need to find out T. So now in the second part, first of all, so the modeled equation becomes P square is equals to 3241 plus 0.984 T cube. And we were supposed to calculate the time when the P was 85,000, which was basically 85. So you've got 85 square equals to 3241 plus 0.984 T cube. So first of all, 85 square minus 3241 is something like 3984 equals to 0.984 T cube. And I'm just going to divide it both the sides. So by dividing 0.984, I'll be having T cube as 4048.78. And now by just taking the cube root, I'll have myself the time, and that is going to be approximately 15.9, which is congruent to 16. So that is the final answer that we were looking for. So that was question number 3. We were just given an equation and we just need to model it like, we always do. Now we've got this question number 4. And the question number 4 is a bit, it requires a lot of trouble to just solve these simplifications. We've got this question number 4, given that y is equals to a to the power of x, expressed in the simplest form in terms of y and a, right? So we just need to express it in simple terms of y and a. And then we've got these two expressions. So what I'm going to do, I'm just gonna, I've got a to the power of 3x plus 1. I'm just gonna, do the first part first of all. I've got a to the power of 3x plus 1. And if you remember, I've got one thing, and that was a to the power of x equals to y. So I need to get ax from here. So what I'm going to do, I'm just going to split it first of all. A to the power of 3x times a to the power of 1. And now you will be having a to the power of x to the power of 3 dot a as well, because I can just split their powers like that. Ax is y. So it would become y cube a. And the final answer is going to be ay cube. So that is how I'm going to do the first part. In the second part, the expression was 5 upon 3a, 1 minus x to the power of minus 2. The second part, the question was uh, 5 upon 3a, 1 minus x to the power of negative 2. So we've got 1 minus x to the power of negative 2. Now what I'm going to do, I'm just going to, solve it down. First of all, I'm going to turn this negative 2 into a positive number. So I would be having 5 times 3a to the power of 1 minus x plus square. And now I'm just going to solve it down. So I would be having 5 times 3 square is 9, a to the power of 1 minus x. That would eventually become 2 minus 2x. And now 5 times 9 is basically 45 times. I'm going to split it down, and I'll be having a square times a to the power of minus 2x. Right after that, I would be having 45a square times a to the power of x to the power of negative 2, because I can split those down. Now since we know that ax is y, so this equation would become 45a square times y to the power of minus 2, and eventually you can write it simply by just doing 45a square divided by y square. So that is how you'll get the final answer, right? Now, use the substitution p is equals to 9 to the power of t to show that the equation, this one, can be written as like this equation. So I'm just going to take that equation, use the substitution, and going to make it look like this one. So I've got it. Question number 3. And given equation and the given equation is, if you remember, the given equation was something like 3 times 4t plus 2 plus 1. Given equation was 3 times 3 to the power of 4t. And what was that? 4t plus 2 plus 1. So I've got 4t plus 2 plus 1. And right after that, I had is equals to 82 times 9 to the power of t is equals to 82 times 9 to the power of t. Now what I'm going to do, I'm just going to, split them down, and I would be having 3 times 3 to the power of 40 times 3 square plus 1 is equals to 82. I'm just going to use the substitution over here since 9t was already p. So I'm just going to write it like this. And now I can just simply write it like 3 times 9, because 3 square is 9, right? Times it by 3 to the power of 40. You remember, we can write it like something, 3 to the power of square to the power of 2t plus 1 as it is equals to 82p. Now what I'll be doing, 3 to the power of, I'm just going to keep the 3 as it is, times 9 plus 3 square is 9. I can split 2t, the power above 2t, as 9t to the power of 2 plus 1 is equals to 82p. Now I'm just going to split it down, and I would be having 3 times 9t is p square. It would become p square plus 1 equals to 82p. And now by just simplifying it down, I would be having 27p square plus 3 equals to 82p. And you would be having 27p square minus 82p plus 3 equals to 0, which was required equation as given above, right? It was required. Now we're just going to solve it, this p part, right? Now you've got the fraction, you've already got over here, and you wrote it like this. Now, what you're going to do, you just need to write it again, use the factorization or whatever method you've got, and you can easily get that, right? So, I'm just going to solve this equation down for the fourth part. So 3 times 27 is 81, and I can just simply write it down like 27p square minus 81p minus p plus 3 equals to 0. And now the common thing out of both of them is 27p, and I'll be left out with p minus 3. Minus 1, I'll be left out with p minus 3 equals to 0. And now from both of these numbers, you've got p minus 3 times 27 minus 1 equals to 0, right? So you'll be having p is equals to 3 from here, and 27p minus 1 equals to 0 from here. And that is going to give you p is equals to 3 and p is equals to 1 by 27. Now, what was p? If you remember your substitution was p to the power of 90, and we are supposed to calculate t. So I'm just going to write it down. P as 9 to the power of t and 3. P as 9 to the power of t and 1 upon 27, right? I can also write it down like, 9 is 3 square. So it would become 3 to the power of tt is equals to 3. 3 to the power of 2t is equals to, 1 upon 27 can be written as 3 to the power of minus 3. Equating their powers up, from here I'll get t is equals to 1 by 2. And from here I'll get t is equals to negative 3 by 2. So these are the two answers I was looking for, right? T is equals to 1 by 2 and t is equals to negative 3 by 2. Now we'll get to the question number 5. The question number 5 says that we've got this function. We need to find dy upon dx in the simplest form. And then it is given that the point P lies on the curve. The line with equation is tangent. What does that mean? That the slope of this equation and the gradient of this equation has to be equal. By keeping them equal, I'll get you this equation. And once I've got this equation, by just solving it down, I'll get myself x and y. Plugging those x and y in this equation, I'll get you k. So first of all, in question number 1, I've got the given equation, and the given equation is x is equals to, y is equals to 4x cube, y is equals to 4x cube plus 2 upon x plus 9. So I just need to differentiate it to get myself dy upon dx. dy upon dx. I can write it like d upon dx times 4x cube plus d upon dx 2 to the power of x minus 1 plus d upon dx times 9. Now I'm just going to solve it down, and I would be having 4 times the differentiation of x cube is going to be 3x square plus 2 times x minus 1. You've got x minus 1, and x minus 1 would become x minus 2 times minus 1 plus 0. And I'll be left out with 12x square minus 2 upon x square. That is the dy upon dx I was looking for. In the very this part, B part, we need to show that the x coordinate of point P satisfies the equation. Point P lies on the curve. Now this is the equation which is tangent to C at P. I do not have P. I'm going to use it as x and y. So first of all, you can easily see that y is equals to k minus 5x in y is equals to mx plus c form can be written as y is equals to negative 5x plus k. So by comparing it with the slope-intercept form, the gradient of this equation comes out to be negative 5. So I'm just going to equate this negative 5 to the gradient of this equation, which is the differentiation. So now in question number 2, since the line is tangent to C, so slope of line should be equal to slope of the curve. Slope of line was negative 5. We just got that, right? It was negative 5. Yeah. And then the gradient, we just got that 12x square minus 2 upon x square. 12x square minus 2 upon x square. I'm just going to simplify it down, and I would be having negative 5, negative 12x square equals to 2 upon x square. multiplying both the sides by x square, I would be having negative 5x square, negative 12x to the power of 4 equals to 2. And now this equation can finally be written as 12x4 plus 5x square plus 2 equals to 0, which was your required equation as well, right? Sorry, it should have been negative 2 over there. So I've got myself negative 2 over here. So you've got 32x to the power of 4 and plus 5x square and minus 2, right? That is how we should be doing this thingy. So now, uh, I'm just going to simplify it down to get myself x. So 2 times 12 is 24. We just need to make some factors to get ourselves 5, and that should be 8 and 3. So 12x4 plus 8x square minus 3x square minus 2 equals to 0. And I would be having, something as common, and that is 4x square. And I'll be left out with 3x square plus, it is 2. Then minus 1 is common, and I'll be left out with 3x square plus 2 equals to 0. So I would be having 3x square plus 2 times 4x square minus 1 equals to 0. And from this equation, I would be having 3x square plus 2 equals to 0. And x square would be negative 3 by 2. That is supposed to be invalid because there would be a square root under the jump. There would be a negative sign under the square root. But over here, I would be having x squared equals to 1 by 4, which is x is equals to plus minus 1 by 2. I'm going to take the positive term because it was given in the question that x has to be greater than 0, right? So x comes out to be 1 by 2. So we've got this equation, and now we are looking for the value of a k. We've got the x coordinate of that equation as well. Now what I'm going to do, I'm just going to plug that value of x, whatever value of x do we have. I'm just going to plug that value of x in the original equation of the curve to get myself y. And once I've got y, I'm just going to, plug those values of x and y in this equation of the line to get myself the final answer, right? So 1 by 2. So C at x is equals to 1 by 2. The equation of the curve at 1 by 2. So y is equals to 4x cube plus 2 upon x plus 9. 4x cube, yani 1 by 2 cube, plus it has to be something like 2 upon x, that would be 1 by 2 plus 9. And by just solving it down, I would be having y is equals to 1 by 2 cube is 8. That should be 1 by 2 plus 4 plus 9. And by just solving it down, I would be having something like y is equals to 27 by 2. So equation of the curve now, I'm just going to plug this equation of the curve now. So equation of the line was y is equals to k minus 5x. Y comes out to be 27 upon 2 and k minus 5x was 1 by 2. So the value of k comes out to be 27 by 2 plus 5 by 2, and that is going to be k. So k would eventually become 30. 27 plus 5 has to be 32 divided by 2, and which ultimately comes out to be 16, right? So that is how you'll get the values of k, right? So we have done almost 5 questions of this paper. I'll get back to you guys with the remaining 4 questions in the next video. Thank you very much.